We also have Franklin Parker with us today. Frank is an undergraduate student at SDSU, majoring in both GIS and architecture. Frank works in the design-build shop on campus where he oversees the operation of the school's Techno CNC Machining Center. Frank also teaches a bi-weekly course to certify students in the CNC machine safety and proper use. Frank assists students and faculty and is currently working on setting up the shop's tool library standards in RhinoCAM for use by students and faculty. Frank will be discussing the Green Wall project.
Hello everybody. So my name's Frank, and actually I just recently graduated from South Dakota State University with a degree in Geographical Information Sciences, and then also a degree in architecture. And so my time at SDSU through the architecture department was spent dealing with, I guess, beyond my regular courses, was spending time with the CNC. And so on the next slide, there's a image of the Green Wall project that I had worked on for a vacuum forming building shop. And how that vacuum forming building shop started was originally we were making geodesic forms. And so the goal was to develop these forms and develop a way to mold or figure out how to basically get to that shape. And so my methodology was through making molds through the CNC. And so I had advanced through that very quickly. And so I decided that I wanted to spend the other half of my building shop working on a project that had originally developed through SOM and case researchers called a phytoremediation wall. And so my objective was then to figure out how to make molds and develop a, basically develop a design for a phytoremediation system where plants can actively filter the air through like coagulation, where it's a rain system that feeds these hydroponic plants by basically pumping up water through the top into the gutter there, and then it drips down into both sides of the pods there. And so the water would then go through the air, and the plants would then filter the air, and it's proven to basically be a very efficient way to filter air without having to use air filters and things like that. And so in the SOM case, they hooked it up to an HVAC system, and they did a bunch of research, and it showed that it was like almost 10 times more effective in filtering air than your regular air filtering in current active systems. So anyways, beyond that, what was really important about this project for me, and that led into the next step of me becoming the CNC sort of operator / teacher and guide, was that I just had spent so much time trying to develop these forms, and I had done it through RhinoCAM. So on the next slide, you'll see basically in the RhinoCAM, the tooling operation, as you can see in the orange, kind of where it's, that's the material color anyways. You're seeing the top of it after it's kind of doing its finishing touches. What I found so nice about being able to use RhinoCAM is that when I initially started, although I didn't fully understand the process right away, I was able to get the results that I needed in order to achieve my objective, which was getting this green wall built. And so it was very easy to run a horizontal mill or a parallel finish, although I did stick with just the horizontal milling. But what I was finding throughout the process is with such a complicated geometry, I was seeing more and more results of the CNC and the translation from RhinoCAM than I was in my geometry, as Jessica had described in her presentation about this like ideal digital world that we're trying to basically fabricate something that's that's so detailed. It requires that knowledge of understanding how the thing needs to be constructed. And so what I had learned through this whole process is that if I wanted to make something so specific as in this like phytoremediation wall, where I wanted to do it out of acrylic next time, what I would need to do is reassess my tooling operations along with the geometry. It wouldn't just be one or the other. I think in some ways they're interdependent, because when you're trying to machine something that needs to be specific in terms of components and parts, with this kind of detail that depending on the tooling operation you use, you need to consider, like what's the width of the bit, what's the, what type of bit am I using, what kind of finish can I expect. Those all played a role in the vacuum forming process. You might not be able to see it all that well, but you can even see the grooves from the tooling process that weren't initially intentional. They kind of worked out because it started to look like tree bark at the end, but it wasn't, initially intentional. And so you'll see in the next slide sort of the final process of that, and that's everything that I had put together in detail. And when you get really close up to it, you start to see a lot of those like misconnections and those parts that I started to miss. But what really all of this is translated into for me was my next job, which was at SDSU at the time, was developing a tool library and developing basically a workbook for students to be able to go through and do more than just create a file, but to understand what these processes are. So if you go into the next slide, you'll see the book. On that first page there, on the top left, you will see sort of the cover, and then on the next one is our CNC illustration that I had created. All of this has been created by me. I used screenshots from RhinoCAM. I drew up that CNC layout in Illustrator, and then I also created the two charts at the bottom there. And so what you're seeing on the bottom left is a guide to use the sort of the tool library that I created. And so that's what students will use. And so I've got different rows in there. Like one of the rows will tell you like your minimum cut width, which really, I state it that way because I want students to understand that depending on what your minimum cut width is, it can determine ultimately what size tool you're going to use for that type of cut, or what kind of, depending on the area that you're going to cut. So I've had students come up to me and say, can I use a 1/2 inch bit for this? But they've got 1/4 inch holes. It's like, no, we can't do that because that's not how it's going to work. And then I would show them then in RhinoCAM, which was nice about RhinoCAM is that it wouldn't let you run those processes, or it would just show you that either in red, or it would just, in the simulation of the tool, it would show you that it doesn't actually cut those holes out. Where in like other products I've used, like VCarve, it won't do that for you, or at least what I've seen with it, or it just won't, it'll do it, but you'll have the wrong information. And what's nice about the simulation tool is that you can see, what your result's going to be before you export it. To a certain level of detail. You're not going to see the full thing. There's things that might happen on the machine that you weren't expecting. But anyways, during my bi-weekly courses, what I was teaching to students was how to do the basic running in RhinoCAM by having them run a test file. And it was the same file for every student initially, and then I got busy with other projects, so I just had them help me with other projects, but I still had them all use just one process, which was a horizontal milling. But the idea behind that is that I was there with them to basically walk them through it and say, yes, you're doing a horizontal milling, but you also need to consider that, what kind of results you're going to get. This is the type of parameters that I have you guys using, but if you use this type of tool or you use this type of parameter, this is the result you're going to get. And it just became more and more complicated. And the test file is actually intended to be a thing that is never the same, as long as someone's there to, as long as I'm there, somebody's there to basically give them a challenge or say, use this parameter instead. And what you'll find is over 2 or 3 different pieces that there are differences, and that's just from changing slight parameters, like changing the height adjustment and things like that. And so really the whole goal was just to get students to understand more in depth what the process is, and that you're not just taking a project and shoving it into the process, where you might see that in manufacturing where we're making multiple products, or there's certain parameters that we need to use, or that wasn't really the goal, because what I'm finding is beyond just cutting topography models, students want to cut out more sophisticated molds, more sophisticated projects, and it just didn't fall in line with the building shops that we have and the type of building shops, especially with Jessica's like Voussoir. You know, that's not something that we could just set up a preset file and have students run. And that's, I don't believe in that intention, because what happened is when I first learned it, I had maybe 10 to 20 minutes of like RhinoCAM time with the CNC person at the time. And I tell you what, I probably went through maybe 50, 60 hours worth of total of like troubleshooting through RhinoCAM in that initial project. And so had I had that understanding of, you know, this is the parameter, this is the type of cuts that I'm setting up, and this is the result of it, or these are the types of tools that I need to use, or even just having a standard tool library. That was really annoying because we didn't have a standard tool library set up. And so every time I wanted to use a tool, I had to go downstairs, measure it, and all this stuff. And so actually through my GIS degree, I'd found out that it's fairly easy to extract databases, and I suppose I could have looked up a tutorial online, but I was just kind of going through the files, and I found that I could pull the tool library out of RhinoCAM. So I pulled the tool library out of RhinoCAM and put it into an Excel sheet and logged all of our tools in there and set up a standard digitally and also physically. So I CNC'd out a tool organizer that matches that chart that you're seeing on the bottom left. So you'll see it's like A1, A2, A3, and then B1, B2, B3. And it's just basically signifying what tool and you know, what size, what speeds, and on the right you'll see a feeds and speeds material that I used by calculating out. I calculated out using a combination of an online guide that I found, and then also using the calculator found in RhinoCAM. So there was a bit of a workaround for that. So the calculator works great in RhinoCAM, except it works as a base, and that was another thing I had to explain to students, is that these are all numbers that are based, and so you're going to want to basically spend some time experimenting. Nothing you ever put on the machine is going to, you know, be exactly what you want the first time around, unless it's something that's been tested before. You know, because if you're running a parallel cut and then you're running a horizontal cut and then you're running a parallel cut, you know, you might not need as fast of a bit on the parallel finish, or you might, you know, need a bigger bit for your horizontal finish. Things like that that took me lots of time just to understand, because I had no one to basically explain these things to me. Initially, the feeds and speeds, how it was explained to me is just, here, use these numbers. But nobody ever took the time to really explain those to me, so that was part of my process too, then, was to say, okay, what do these numbers mean, and how can I, you know, break these down in a way that students can understand it. And so ultimately at the end of all of this, what I had found is that students, they weren't using it as often as I was. And maybe that's just because there wasn't a level of comfortability with it. But during the process, I had found that they were asking the right questions, and I felt I was leading them down the right road, because it was like, okay, well, here's this test, and then they would take this written test, and it would be like, oh, but is this the right answer? And I would, you know, intentionally ask them difficult or tricky questions, more for them to ask me, you know, what does this mean, or what are you trying to ask her? Is that right? You know, why would you do that? And I felt at the end of it that they had more of a common sense about the machine than someone who had, you know, no guidance and had to do this from scratch. And so I guess my comment about RhinoCAM with that is, what's great is that for somebody like me, you know, I can go downstairs and run, you know, about anything I want. But there is still a level of complexity, though, to RhinoCAM, which is nice, where I can go through and I can set up very precise parameters, and I can set up these projects very quickly using, you know, a standard tool library. And so I guess through the whole learning process, I'm hoping that, yeah, Jessica and the rest of the faculty can sort of continue this education, and maybe reconsider having somebody assigned to this and then always having somebody underneath of them, so this knowledge is just constantly going. Because this book that I made, I think it's about, I don't remember, maybe 12 to 15 pages, and honestly, it's very, very short. And you'll find, very thick textbooks online of very thorough CNC technologies. So I guess if I had more time or something, I'd probably write a very thicker book. But it's much easier if you have somebody there to explain these processes to them, I think, than trying to force somebody to read through them, because they're not going to consider all of these things that you have through experience. So I think experience is very important with the machine, and just having somebody comfortable there helping students. And it's been very effective, I think. So I guess that kind of concludes what my role was at South Dakota State University.
Thanks, Frank. We appreciate that presentation. If you don't mind, hang on to see if we have any questions at the end of the program. Next, we're going to have a demonstration of MecSoft's educational products. So I hope everybody can see the part that I have on the screen. What I have here is two of the components in Frank's remediation system that he modeled in Rhino. And he sliced them in this thicknesses, because that was the stock material that he had. So we got two of the components laid out, and we've got our stock already defined. We've got our machine defined. We've got the post set up. We have our stock, and we have a setup already determined here. So let's go ahead and create a roughing operation, a horizontal roughing for this part. Now, you'll see that, let's turn the stock off a moment. You'll see that I have some curves here. These are just offset curves from the silhouette perimeter of the part. And we added some tabs here. These are just small blocks in Rhino. They don't have to be joined. I just modeled them to attach past the part and to move beyond past this perimeter. Now what that's going to do is that's going to allow us to machine just the area of the model that we need to. We don't want to waste any time machining stock out here or in areas that doesn't need to be machined. So we're going to use this perimeter as a containment area. So let's go ahead and create a three-axis horizontal roughing operation. We've got our containment area selected. For the tool, we'll go ahead and use Frank's A7, which is a 1/2-inch flat end mill. Beads and speeds, we'll load those from the tool. Clearance, we'll leave those set to automatic. For the cut parameters, again, we're going to leave 25 thousandths of stock away from the part, and we'll use an offset cut pattern. And again, let's set the step over to say 40%. And for the step down, we'll leave that set to 50%. And we want to cut all the way from the top of the part down to the bottom, all the way through the stock, so we don't need to contain it to any specific levels. So we'll leave the rest of the tabs set to the default parameters and pick generate. So what it's doing is calculating in Z levels how much stock to remove within this perimeter area down to the part. So you see it didn't cut out here in the stock area that we didn't want to cut. It maintained it within our perimeter that we selected, and it cut it in levels. And let's take a look at those levels. So let's go ahead and run a simulation of this. Select our operation. Turn our toolpath off so we can see the simulation good. Nope, might help if we turn the stock on. So there's our horizontal roughing operation. As you can see, the tabbed areas were not cut, and it serves to anchor the part area to the remaining stock and keep it stabilized on the CNC machine. Now, I also have a horizontal finishing operation defined. To save time here, I'll go ahead and show you what that operation looks like when it's completed. So I hope you can see that, my screen now. I've got the finishing operation defined. It's a horizontal finishing operation. We'll go ahead and take a look at it. We got the cut parameters, and we got cut levels set to 10%, which is a pretty fine step down. This will determine how the finish on the resulting finish on the part. So if you don't mind a rougher finish on the part, you can set this to a larger value, and then you can do some hand sanding or finishing on the sidewalls of the part to remove the cusping areas. For this part, I went ahead and set it at 10%. And let's take a look at this nice horizontal finishing operation. Now, the product also runs as a standalone called Visual CAM, and that doesn't require any additional CAD system. It comes with Visual CAD, our standalone CAD product, and also it runs Visual CAM for SolidWorks. And let me show you what both of those look like real quick here. So hopefully you can see my screen here. We have Visual CAM loaded. We have Frank's part displayed on the screen, and we can see the horizontal finishing operation defined here. And also let me show you what it looks like in SolidWorks. So here you see SolidWorks 2017, and we have Visual CAM plugin installed on the right. Now, regardless of which program you run the plugin in, the machining browser and all of the techniques that you use to create toolpaths are nearly identical. So you can easily move from one platform to another. Also, Visual CAM will run within SolidWorks. It's a Gold Star certified program for SolidWorks, and it runs in SolidWorks 2010 all the way up to 2017.